who's based at Buist. I've known Dimane for ever since I first visited Buist in 2017, I think, and I'm really glad that he's able to take time out of his very busy schedule. He's been whizzing all over the world to do with this BOTSAT project of recent times. So I'm really glad he's been able to spare the time to give us the talk tonight. But Dimane is a computer scientist, as I say, he's based at Buist. He did his BSc at UB, and then he came to the UK, to Newcastle-on-Tyne, Newcastle University in the UK, where he did his MSc and PhD in computer science. He's held various senior positions since returning to Botswana, senior positions in technology and innovation at Buist. And from 2021, he's been the project lead of the BOTSAT project, while he's also remained active in all the other work he does across a very broad front. So without further ado, I'd like to hand over to Dimane to tell us about the BOTSAT project, Botswana's journey into space and beyond. Thank you.
Thank you, Prof. Bode. I can't see myself. I'm not sure how I look, whether I have my face cut or not. I hope
No, you're okay. You're
Okay,
okay.
okay,
Yeah,
fine.
yeah.
You can see my T-shirt. Okay. All right.
Just
Thank you.
about, yes.
Yeah. Thank you.
SpaceX. Yeah.
Yes,
Thank
we
you.
can. It's an attractive T-shirt.
Yes. 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 Thank you, colleagues. I'm really excited at doing this today. I would like to say that I think for the first time, I know my colleague who is in audience here, Prof. House, he always says you normally take too short time to present with your 15 slides. I have to say that at least I will double that. That will make him a little bit happy because there are now 24 slides. It is about BOTSAT. Now, the story of BOTSAT is amazing. I will just give you a perspective of BOTSAT. It is an endeavor by a country with only 2.5 million people as a population. I remember when I did presentations to our colleagues in Nigeria, or the Nigerian colleagues, I was not in Nigeria, by the way. They were asking me about, they said, look, you Nigeria, you have done more than 10 launches of the satellite. But we just started, but why are you so excited about our project? And then my colleague and those colleagues from Nigeria said, look, Botswana's population is like a small street in Lagos. So I'm imagining that street launching a satellite. And then that's exactly what we are going to do. Let me say, okay, if you can see my next slide, is it moving?
Yeah, it is.
It
Yeah,
is
Yeah,
it's the
moving.
yeah,
It
abstract.
is.
Yeah.
Yeah, yeah.
yes,
It is.
that's what you have seen. But I just want to go straight to that particular device, or what we call BOTSAT-1. The one on the right hand side, just like a number plate or plate number of a vehicle. It is the first satellite out of BOTSAT, the project called BOTSAT. It looks almost identical, exactly like this. It is our model. I mean, this is the picture of the BOTSAT-1. It is what is called a 3U, and it has got solar panels that flap out, and what you see at the bottom there, are just antennas. So this is BOTSAT-1 that we are going to launch with SpaceX in February. More on that just a bit later. Now it is the first satellite. We have partnered with local, international experts. Some of them you know about them in this, and we just launched it to be specific, to tackle the national challenges in urban planning, and environment conservation. Now those problem areas, they even dictate the orbit parameters of the satellite. That is why we decided that it should be a sun synchronous satellite. It should sort of go over a same location over Botswana, uh, over some orbital cycles. BOTSAT-1, it is nothing much more than the camera. The camera, it is the main payload. Everything else is just supporting this camera. It is a hyperspectral camera, and it is not so much bigger than your palm opened, because it's about 10 centimeters, just like maybe more or less the same length as the iPhone. But as you'll see later on, it will do wonders. In fact, when I talked to our Nigerian counterparts, they were saying that, you know what, as late adopters of technology, we have launched satellites that are the sizes of cars, whose resolution is even far more inferior than this particular small camera. Now, this camera has got 120 spectral bands, and I think the beauty of the camera is it is not just that it can do these hyperspectral bands. It is much more software defined. Nothing is hard coded, so we were able to tune through all these spectral bands as we wish on the ground, on our ground station, depending on what we want to observe. And one of the things that I learned in this project was, by the way, even chlorophyll, if you want to observe some vegetation, even chlorophyll, they emit different wavelengths. So chlorophyll for maize is different from chlorophyll of, let's say, a mopani tree or banana tree. So that is catered for largely in the spectral window. Now, this is more or less the more complete spectral band that we normally we are aware of. But if you can see my mouse, this camera starts somewhere around 400 nm. It almost covers the whole visible light spectrum width or window. Now, what is amazing about this camera in terms of the wavelength, it is jumping slightly into the infrared region, up to 800 or 850, not to 1800. Now, what does it tell us? It tells us that there will be some nocturnal interesting activities that we can do, that we can observe with this camera, the night-based observations. We are happy that it can sort of cover some applications better than others in this, but the ones that we prioritize, they are wholly covered. Environmental monitoring, it can cover that. Water detection, it can do that, but you can see it may struggle a little bit because the bands that are very good for water detection are 900 upwards, but it can do just below 900, but it can still give us some settlement and urban areas. That one, it can also do crops and vegetation. 700 bands is just fine with it. Animal habitat, soil analysis, especially for mining. But you can see the soil analysis is way off. But I can tell you that this can actually help in even in mineral explorations. As you can see, it can do it can do rock identification. It's way off band, somewhat, of course, cloud characterization. Now we have as where are we? We have assembled this. These are the BOOST engineers doing the tests. One of the tests that I was really scared to know about, or eager to know about, even nervous, was what we call the thermal test. The thermal test is they are testing this satellite whether it can sustain the heat or the ultraviolet that it's exposed to when it's or when it's at orbit altitude. So I'm happy to say that we have just done other tests that are done. It's working well. The only tests that are left are the loading or the vibration test that is the equivalent to Falcon 9 as it launches it. And we are going to do that in a special facility in Germany. Our engineer will go there. The Dr. Musalis that you see on the left. Engineers having fun with the satellite. Um, One of the things that we are also proud of in this project is that we have human capital active program. The first cohort was more inclined towards engineering. Am I still there? Mike?
Yeah.
Okay, good. Yeah, the very
Yes, you
first.
are.
Okay, thank you. The very first cohort was engineering biased. Now, as we went on, we said, look, now we want people who can answer the why question. Why, then what? So we have a satellite, then what? Now this the newest cohort that has got about 3 months with us. There are about 10 of them. We have a space for 15. They are more on science or application side of things, almost all of them. So we are very bold that we want these minds, young minds. We didn't admit anybody older than 35. Actually, Prof. Hillhouse tried to apply, but he was probably twice that age. We couldn't admit him. So we are young ones doing masters and PhDs on the applications of satellite, not just of ours. Now, let me tell you this. I know some of my colleagues will say, why these millions? By the way, almost half of the budget is going to them. Those are the applications for the satellite. This is what we are going to launch. We're launching with. It is called Space Falcon 9. But the flight that we are going to be in, you can Google this. It will be Falcon 9 flies several times because it's a reusable rocket. Every time it flies, it is given a flight number, just like a flight number of the normal cargo or passenger flights. So the flight that was on in October was called Falcon 9 Transporter 12. So BOTSAT-1 is going to be in Transporter 13. That will be end of February to be precise. We have just been given that date, even though it is normally secret. SpaceX doesn't like exposing too much of the date and the time. It's going to be on the 1st of March. By the way, February, I'm not sure whether it's leap year, 28th or 29th. Just after that, we will be launching this, using this. Why is it important? It actually beefs us our profile. We have a ground station. Unlike other African countries, many of them, they launched even 1U, like 1/3 of the size of our satellite. They normally don't have ground station, but we decided that we are going to invest in the ground station. So this is our ground station that is waiting for the satellite to beam images down. How will it work? It will do swaps from east to west. Botswana, we are very lucky that the sort of the orientation or the bearing of Botswana is more aligned, perfectly aligned north-south. This satellite is going to be a polar orbital satellite, which is good. The inclination about 98 degrees, 98 degrees, which means that it's more or less making a perfect 90 degree with the equator. And then it will do swaps. It will go around Earth something like 14 times in 24 hours. But over Botswana, about 4 times in 24 hours. For every time it does those swaps to do the observations, the swath or the width of that strip as it scans the Earth will be 32 kilometers, which is not bad. We have, it depends on how you look at BOTSAT. If you are the VC, you see it as a directorate within BOOST. That's how it has to operate with some structures and stuff. Right now, there's project lead, myself, and then there's lead engineer. Most of these boxes are not filled, but at the moment there's 6 of us that are on the ground together with, if you see at the top there, management committees and volunteers at BOOST. There are about 60 or more people volunteering doing stuff on this project, actually including the person who's speaking now. I'm not really paid to be a project lead, even though I have sleepless night about it, which is fun. Or commensurate with what I do. Let me say that. This project has exposed us. Mike, I heard you say he's been trotting the globe. No, actually, the person who is traveling more is my lead engineer. He's the guy who is always going around. He's just from Japan. He was from Bulgaria. Next week, he's going to Germany along with the satellite to do the vibration test before he sends it to SpaceX. So we sort of have some links with international partners. This SpaceX, this project has led us even into connecting with Starlink. Starlink now have pledged some resources of a particular project that they're going to work with BOTSAT, which is good. Even though Starlink is about the internet, BOTSAT is about Earth observation, we will actually merge or meet halfway. This was we are ready to launch end of February. Cost. This is the fun part. And this is where I made the VCO aware that the reason why you deserve, I think, praise is this. Your project, which is doing an excellent job, we don't have a space agency in Botswana. We didn't have full-time staff until recently, like a couple of months ago. Yet you managed to have about 60 people, including Prof. Hillhouse, who is here, work on the project for 4 years, and then you drove down the cost to $600,000 a year. So this is the project that is making a lot of noise with associations like SpaceX, yet 600,000 a year. ZimSat, which only launched a 1U so far. I think I hear that they launched the second one. 1U meaning a third of the size. They have got a space agency instead of just in part of the university. And then their expenditure is $13 million a year. So this is actually breaking news for us that we managed to do all this. Thank you, Mike. I would like to say that I forgot to just mention that the SpaceX recently asked us about two things. They asked us, we have two stops. One, we have 512 kilometers. The second one, we have 600. Choose. Of course, it was very easy to choose. We knew what Mantis wanted. We knew the camera. We knew which altitude it would want. I'm happy to say that we are now sorted with SpaceX. They're going to launch our satellite at 510 kilometer altitude. That will be the optimal sort of altitude for the camera and what the applications that it will do. With that, Mike, I think I'll stop here for questions,
Okay.
maybe, or comments. Yes, thank you.
Yep. Well, thank you, Dimane. I learned so much more in this talk than I'd known about the project in the last few years. And it's a very exciting time. We all look forward to the end of February, beginning of March, when we actually see the launch of the satellite and then the operation of the satellite over subsequent years. So yes, questions. David.
Go on.
Oh, sorry.
Okay, I've got a question. Congratulations. That was so interesting. Thank you. Will we be told when this is flying overhead so that we can see it and be proud of what Botswana has achieved and point it to our neighbors? That's the first question. The second question is, what size objects can you see on the Earth? For instance, could you do a survey of the number of elephants in Botswana? Something like that. Or go smaller than that? Over to you.
Thank you, Harold, for that question. It's important. The first one is easy to answer. We have a committee that is almost autonomous of what they want from the project. That has got a chairperson. The outgoing one is probably how there's a new one. There are 60 people or more and other multiple organizations that are working with us. We are ramping up. There's going to be some noise now towards February. It will start now. You won't hear about it next year, but now. So you'll see some activities, television presentations, press. During the launch in February, we're actually going to invite CNN, BBC, so they will be here. The world will know about us. Even the region. I can tell you right now that, for example, next week, there will be about 20 universities competing in Harare of SADC. But we decided that the BOOST teams, all of them, all sporting codes, will be draped and wearing a BOTSAT big logo on their chest because they are interacting with other universities. The other one was that's I actually missed that. I don't know how. Thank you for that question. The other one is the resolution. You are asking about the resolution. The resolution of this initially, because I was actually judging it against the normal resolutions of what we have in cameras or iPhones. The resolution of this is 12 meters. Now, if your elephant is 12 meters or bigger, it will be seen. So somewhat, yes, I would say that. By the way, some images you can make a lot of sense out of them by just looking at the group head of elephants instead of just one elephant. So it's 12 meters, the resolution. 1 pixel will be equivalent to 12 meters. And I was told, I was not aware and experienced until I joined the project. some other experts, Nigeria was saying, look, we have to buy images of 12 meters to start with to observe our oceans, our vegetation. So your camera is good, because I was sort of complaining. Then they said, none of our 10 satellites that we launched several years ago are better than this one. But we still use them anyway. They are in the 24-meter range or 30-meter resolution. To answer you, yes and no, but largely yes. That's one of the projects that Starlink wants to jump into this project to augment all the observations with Starlink satellite routers to actually beef up the resolution.
Thank you very much. That's a very good answer. Thank you.
Thank you, Harold.
Okay. David, is that your hand up?
Yes, it is. I'd
Yeah.
like to thank Dr.
Go.
Mpoeleng. It was really fascinating. I'd like to make sure I understood this. Did he say that the satellite was designed and built in Botswana? And the other thing I'm sort of curious about, looking at the picture he's got on the screen now, is how does that thing orientate itself once it's released from the SpaceX rocket? Thank you.
Yeah, thank you. Thank you for that question. No, this was largely, I would say 70% largely an input of our engineering partner called BOTSAT in Bulgaria. We were more on the design, the spec, and in some cases configuration of what it should do, and also the tests. So our side was maybe, I would say, 30%. I would say that, as you know, a project is largely other softer things around it, but I would say we co-developed it within BOTSAT. The other question was, what was it, by the way? It was the other question was,
when this is released. Yeah, sorry, David, go on.
Oh yeah, the orientation. Yes, yeah, the orientation. It is going to be downward facing, and it has got some attitude control mechanisms that can orientate the camera the way we may want to a certain degree. So it will be looking down on Earth. So we'll actually be observing Earth 14 times around Earth in 24 hours. There will be situations where this is where it becomes very interesting, because even the satellite platform itself is software defined. You can develop optimization algorithms that minimize the utilization of the battery depending on whether the solar panels are facing the sun, or so we can actually literally face, sort of orientate within degrees of 30 or 45 degrees, orientate it the way we want. Control, we can look where we want it to look with some limitations, but dominantly it's Earth observation camera, it will be facing downward. If you look at the if you look at this picture, you won't be seeing it there. It is actually 90-degree orientation to this vertical standing up satellite. So it will be facing down.
Thank you. And presumably the whole thing is too small to be seen from Earth.
Actually, that is what amazed me. It is a camera. If you know Botswana or UK, the camera is in Newcastle. The observation the Earth is at Southampton, but it can still see an elephant, and is the size of the palm of your hand. It can see an elephant from 400 miles away, or 370 miles away, which is about 510 kilometers. And it's hyperspectral, meaning different spectrums and all that.
But I think, David, were you meaning whether you can, and it goes back to something Harold said, whether you'd be able to see this in the night sky? And because it is so, yes. Because it's so small, I suspect you would probably need at least binoculars. But anyway, and know exactly where it is going to be. But
yeah, I remember that question now. No, you won't see it. I'm sorry, you won't see it. We struggle to see a a 70-meter Boeing 747 when it's only 15 kilometers above Earth. This is only, it's a ruler, and it's at 510 kilometers, so it will be impossible to see it.
Yeah. Okay, I've got another
Dr.
hand.
Dimane, thank you
Oh,
so
yeah.
much for this presentation. I think it was just quite fascinating and informative. Everything about it is fascinating to me, but just a few questions. So the launch of this satellite would be SpaceX rocket, Falcon 9 rocket, which will be launched in the US, right?
In Florida, yes.
In Florida, okay.
Yes.
Yes, and then the next thing is this beautiful camera, the hyperspectral camera, and all its functions. One particular function, I just want to ask you and get more information. It's about the analysis of crop health and vegetation across Botswana. What is it that the camera would capture in order to give this feedback to the ministry or to BOOST? What exactly does this camera capture through its capacity?
A good question. Like I said, it is software defined. We are in full control right on the ground station. There could be other things that we didn't think of. Then you say, oh, by the way, we should actually observe pollution. And there are some particles in the pollution that are emitting some certain wavelength that we can pick from this camera. Then we observe pollution. But of course, we needed to have a startup justification business case for it. And the business case for it was what? What concerns Botswana? Environment, that of course includes grazing land, vegetation, crop, yield. It will observe all those settlements and food security. So it will observe whatever you want it to observe, because it will not be hardwired inside the camera what you want to observe. It will be controlled by us for the lifespan of the camera.
Okay.
Yeah.
Yeah.
Thank you, buddy. Thank you, Gian.
Yeah, David, you have another question?
Oh, it's just a silly one. I hope that President Boko will be there in Florida in February.
Okay, good one. Initially, we had wanted, we had planned that the previous president was not gonna go there, because in Florida, SpaceX has got only two positions, two slots for people to go observe at a VIP slot. But it looks like it's gonna be President Boko going there, and then I'm happy to say that the new administration, it is so perfectly aligned with this project. And in fact, we made contribution to the his SONA recently, of what he should say. And then that's why you saw in SONA SpaceX, and then we just naturally link with SpaceX in that way. So Boko, I can tell you that naturally he's got a buy-in.
Excellent.
Yeah.
That's great. Yeah. Just going back to the previous point, I believe it's not my speciality at all, but I believe that you can actually, from space, through the sort of imagery that the satellite will do, you can spot diseases in crops before you can spot them on the ground. So, that's just a small example of the sort of thing you can do.
Okay.
Yeah, especially of food crops. They say sometimes have got very conspicuous, observable characteristics that you can definitely say. For example, maize has got a big leaf. You have several of them. There's a patch that is got, it's showing some signs, yellowish. You can pick it from this camera.
Okay.
Okay.
You also mentioned that even in mineral, in deposits, exploration, in the pre-exploration stage, how would this camera have that kind of resolution to be able to see underground, into several kilometers deep underground? I can't figure that one out.
Yeah, actually, I'm not a mining expert, and I'm also, I know I told myself that it's either computer science or geology. I love geology. I know I have my friend here in attendance, Prof. Mudisi. I really wanted to do geology. I think maybe because of him. However, even though I'm not an expert, I can tell you this: there is a lot that can reveal the secret of the minerals of what you observe on the surface, not underground, including vegetation itself.
Yes.
Some vegetations they can pinpoint where manganese is by that characteristics. They
Okay.
can pinpoint where uranium is. So even the types of rocks. So that is where the camera will be useful as well. In fact, I was telling my colleague Prof. Hillhouse that, but as I am in this project, I thought it could observe this. Now I realize that this camera can even do mineral explorations, which is what we are going to throw in the next cohort of students that we want them to use it for mineral
Yes.
explorations. Many of these questions that you are asking are going to be answered by the current postgraduate students.
So what size of team would you have on ground to develop software, to analyze the data, to interpret the data, to churn it out into reports? I mean, that sounds mind-boggling. It
It
sounds
it
big.
is. It is about 10, but even when I say about 10, we are not enough. The good thing is softwares have taken over. AI, you have tools that are ready now to do all that.
Oh,
Yeah.
oh yes.
Yeah, so we are optimal. That is why we are spending only 600,000 a year dollar instead of $13 million a year. And
Okay.
yes, the students will also enlighten us, and then they will have some suggestions of what to do with it. They will be the ones we told them. They will be the ones answering parliamentary questions because they are
Yes.
in that area. A parliamentary
Yes.
question: how does it help in Okavango Delta when we have diseases? Then the students will answer that with a more insightful background because
Okay.
of that study. So not
Oh,
us. We are just facilitators running project, doing the engineering. Somebody else should answer those questions. Ministries, they're gonna use this data. They're gonna say, no, we want
yes.
it like that, and then we can even commercialize it. By the way, just
Sure.
one more last thing. One or two of the students that are going to be at UB, they are going to be specifically on business side of the project. Two,
Wow. That's tremendous
they
potential. Yes.
yes, we made it that deliberate. Two, all these students that we see from Okavango Research Institute, Buang, UB, BUST, they are studying at those institutions. They are not studying at BUST. We want it to be heterogeneous to avoid inbreeding of ideas. So they are doing the researches there at Buang for food security, ORI for environment, UB for business and also for engineering and science,
Yeah.
BUST. So all these students, it's fun. It's really a rainbow of students having just chewing up this project with that energy.
Fascinating. Do these satellites have a lifespan?
5 years.
5 years. That's all.
Yeah, and this one will probably go to 7 years. That is why BOTSAT government has budgeted this, or they have put it in NDP 12. It's going to be running for 5 years
Okay.
anyway. So the
Okay.
next, we are not stopping here.
Yes.
Next year, right now, the team is busy crafting BOTSAT-2 because we are done with BOTSAT-1. So they're doing
Oh,
BOTSAT-2.
okay.
So BOTSAT-2, you may see it as double the size with better
Yes.
resolution of 2 meters or 1 meter and fascinating applications at that stage.
Fascinating. Thank you so much.
You are welcome, Gyan.
Okay. I'm also quite pleased to see that Hamotso and the AVN team have also been assisting you
Oh,
with
yes.
some of this, which integrates the two from the astronomy side through to there's all the technical stuff on the satellite. So
Yeah.
that's really great.
Yeah, I forgot to acknowledge that when we started, it was just me and the engineering guy. Let me tell you this: we recruited for about 6 months. AVN astronomy, the skills they almost overlap 90%. So they were worked on this. I can say a lot about how we really work together so well.
Yeah.
So they actually kickstarted this project.
Okay. Any other questions? If not, then I'd really like to thank.
Hello, Mike.
Oh yeah, go ahead. Hamotso, yeah.
Yeah, I just wanted to make a comment around the already operational ground station. What Dimane did not talk about about the ground station is it was commissioned in 2022. It has been doing work operating because it was not licensed. It has just been doing accepting data from those free satellites, but it is a ground station that is fully operational, or does all the operations. It's just waiting for the actual satellite to be launched. So it was actually a deliberate strategy. Have the ground station work, that we are sure that it is working. By the time we launch the satellite, now we know that the ground station is fully operational. It's just a matter of now tracking our own satellite. I just wanted to make that comment. Thank you.
Yeah. Thank you, Retelo. Yes, we are receiving images right now. You seen this?
Okay. No, that was a good point. But if there are no more questions, then I'd like to thank Dimane again for an excellent talk. And as I said before, we all look forward to successful launch and following the results that will then flow from this satellite, which, you know, as you've emphasized, cover a whole swathe of different parts of the economy of the country and the well-being of the people. And also it's very pleasing to see this human capital development side of things taking center stage as well, which is obviously important for future development. And we will follow BOTSAT-2 and its successors into the future. So thanks again, Dimane. Excellent talk. And I look forward to seeing you in person sometime next year. That's the talk for tonight. The members of the committee have a committee meeting which will immediately follow this. So I'll see some of you again in a few minutes, but everybody else, have a good evening. Thanks again for attending. Thanks again to our speakers, to Harold and Dimane, and take care. Have a good evening, everybody. Thank you.
Bye.
Thank you.
Bye.
Thank you. Good night.
Bye.
Bye.